Hey guys, let's consider more examples. Uh, right, so this is an initial value problem, right? So dy by dx is equal to x times sine of y, and the initial condition is defined by y of 0 is equal to 1. In this domain is all points in infinite plane such that the modulus of x less than or equal to 2. So let's check whether this initial value problem is Lipschitz continuous with respect to y. So let's check this function. This function is Lipschitz continuous with respect to y in this domain, right? Alright, this is your function here. So function of this is f x comma y is defined by this, right? Let's take that. So you can see that this function is continuous on this domain, right? So that means, yep, this system has solutions, right? If this function is Lipschitz continuous on this domain, we can say this. So that we can say there exists a unique solution. So the solution is unique, right? Alright, let's take, so yep, any 2 points in the domain. So here, yep, if you want to show this one is ellipsis, I think you can prove that it is enough to show this the derivative of f with respect to y is bounded on this domain. You can show that, but I don't have time to prove that. So remember that the derivative of f with respect to y is bounded if the derivative of f with respect to y in this domain is bounded. Then we can say this function is Lipschitz continuous. Alright, let's check that. The derivative of f, right? So derivative of f with respect to y is x times cos y. The modulus of that, right, is less than or equal to modulus of x by cos y is bounded by 1, right? So we know that in this domain, so this is, so x comma y is any point in the domain, right? So the modulus of x is less than or equal to 2, right? Because x comma y is a point in D, right? Therefore, this derivative, the first derivative with respect to y, the derivative of f with respect to y is bounded on this domain. Therefore, we can say f is Lipschitz continuous. That means this system has a unique solution, right? Okay, if you look at this initial value problem here, so dy by dx is equal to 2y over x, and the initial condition is this one, and your domain is any point in your infinite plane such that x in between 0 and 1 not equal, right? In between 0 and 1, right? So we know that f x comma y is 2y over x, which is continuous on this domain, right? Continuous on this domain. Let's check whether it is Lipschitz or not, right? And if you find the solution of this, you will see that can find that the solution to this initial value system. So this is the solution to this system, right? So y equals c times x squared. C can be any real number, right? So you can verify that, right? Either, or you can separate variables, and integrate, right? Then you get this solution, right? So this is a solution. Here you have infinitely many solutions because c can be any real number, right? This c, the value of c is a real number, right? Therefore this system has infinitely many solutions, right? Let's check whether this has a unique solution here. So let's I think no, right? If you compute the derivative of f with respect to y, you get 2 over x. So this is not bounded on this domain. On this domain, this is not bounded, right? This is not bounded, right? So this is not bounded. I don't write this. It's not bounded. It's not bounded. It's not bounded on the. Therefore, this is if it's not Lipschitz-continuous. That means yep, solution is not unique. That means yep, this has infinitely many solutions. This is an example, right? Hope you understood Lipschitz-continuous, right? So how to check a function whether it is Lipschitz or not. This one also valid, right? If you find the derivative with respect to y, if you want to check this function, whether this function is Lipschitz or not, just find the derivative with respect to the dependent variable y, then see whether that derivative is bounded over that domain D, right? Then we say if it is bounded, then we say it is Lipschitz. Okay, all right.